Morning, everybody. Welcome to the webinar. I'm Tom Bosmans, application manager from Baltimore Aircoil company. Just a small introduction. Baltimore is the global leader of evaporative, hybrid, and adiabatic cooler, and we also provide ice thermal storage. I hope that everybody can see the presentation. So first of all, I want to discuss the agenda of today. Briefly, we will talk about the global trends that are now in data centers. We'll talk about the global support. Then we go deeper into the different types of data centers and the solutions that we can provide for this. We will talk also about the data center trends, more specific, the increasing temperatures that we see in data centers. And to finalize, we will talk about a little bit about free cooling, and we give some key takeaways. So first of all, we start with the global trends. Here we will discuss the growth drivers, the operations, and the customer needs. So everybody knows that a lot of businesses around the world depend on the data centers these days to store, to manage, and also to share their data. But we also have compiled some lesser known facts, as you can see here on the screen. For example, point 2, you can see that a large data center nowadays uses as much as electricity as a small US town, which is quite remarkable. And as you can see on topic 6, by 2020, the data centers will use 1/5 of the world's electricity, which is quite high. So you can see, to summarize, that data centers are globally active, and also that everybody is looking for reliable energy saving solutions. When we talk about the growth drivers, we can make a distinction between two different parts. On one hand, we have the edge computing, and that's related to the Internet of Things. So all the devices that are connected to each other via the internet. Here, with edge computing, it's important that the data is analyzed, where the data is produced, and where the data is consumed. Especially for real-time applications, it's very important that they do not suffer from any latency issues that could affect the application performance. So they need a fast processing speed, and an example is smart city or smart buildings, things like that. So what are their needs, their customer needs? You can see they want to have a flexible footprint, because often they are in very confined, limited spaces. There is a high heat transfer. They require a high reliability, and they're looking for plug-and-play devices. On the other hand, we have the growth of the large cloud data centers. Everybody is connected to the internet, and there is an increasing demand for storage and processing power. So we see that this is a very important topic, the cloud-based data centers. What they need is 365 days a year round reliability. They also have a high heat transfer, and they also want some redundancy. And because they are big in volume, there are a lot of servers in this cloud-based data center. They're looking for a reduced energy usage. When we look then to the global trends related to the operations, we can tell that very important for a data center operation is that there's a continuous operation. So 24/7 and 365 days a year, there needs to be a reliable, continuous operation. There needs to be a certain amount of redundancy, and due to this continuous operation, energy usage reduction is very much required. In respect to that one, there is a key parameter for the data centers, and that's called PUE. PUE is the power usage effectiveness. It is the total facility power compared to the IT power. So it is the power that goes to the servers. The lower the PUE, the more efficient your data center is these days. You will see in Europe PUEs of 1.2, and we know that the average last year was 1.7. But we see also for older data centers that they go higher, like 2.0, even 3 or 4. So it depends of the date of construction, but also there are a lot of other factors that have a big influence on your POE. Next to the aim for reduced energy usage, they're also looking for a water reduction. So the data center should be able to maintain its operation even if the water supply is interrupted. So therefore, we're looking for redundancy, and that can be, for example, a water storage tank. And in general, we are looking for reduced water usage. So with regards to operations, we want to have a continuous operation with a reduced energy consumption and a reduced water consumption. When we look next to the owners and engineers, contractors, what kind of trends do we see and what do they need? We see that for the large data centers, where there's a single owner, you can see some examples like the Googles, the IBMs, and the Microsoft of these worlds. They are having a construction globally, and they're looking for a partner, a single partner that understands their data center needs all over the world. To give an example, on the right hand of your slide, you can have an owner that is in country A, for example, in the US. You can have an engineer that is located in the Middle East, and you can have a contractor that will do the site works in another country. So it's very important that the partner that they are looking for is globally active and that they can support the project from design phase to the construction and even in the after sales all over the world, that all the products that they provide have the same quality and that all the services have the same standards. That is very important with regards to owners and engineers. How can BAC meet this demand? We have a global support network through our sales and also via our BAC key accounts. And on top of that, you can see that there are in different regions, we have data center hubs or data center teams where the stars are shown. And there is a high level of data center knowledge that can support your projects from the beginning till the end and even in the after sales. So that was the global trends. And now we arrived to the second chapter, the different type of data centers and the corresponding cooling solutions that we have. First of all, we start with the edge computing. We already discussed before that edge computing is mostly it's a smaller data center, but the key distinction is here is the location and the connectivity. So the data center is where the data is produced and where the data center where the information is consumed. The criticality of the content can go from very low, like movies, to very high. Just imagine self-driving cars in the future. So there is a lot of interaction, and this information needs to be processed very quickly and must be accessible very quickly. So that's one thing. What do these data center needs? In fact, these data centers are modular and they should be close to the customers. They are scalable and they're looking for smaller tonnages. A continuous operation, preferably operated remotely. And of course, the power and the cooling should be maintained at all times. So there should be a high level of reliability and a higher level of redundancy in this kind of data centers. What kind of cooling solution can we provide or should we provide for this type of data centers? It should be a modular flexible installation with a very small tonnage, approximately 20 tons. It should be preferably a self-contained product, factory assembled, that can optimize the energy and water usage with a certain level of redundancy. And we're looking for a limited to no maintenance of this product or this solution. When we look to our products and we think about cooling towers for the edge computing, we were looking to the modular hybrid evaporative coolers. These kind of products are very small and very compact. They're able to fit in a freight elevator and they don't need any additional rigging. We can add different modules later on, and it has a very small footprint, as mentioned before. These kind of edge computing data centers are very compact because they are often inside the cities. So this is the ideal solution for the edge computing data centers. Next to the edge computing, we have another group, and these are the enterprise co-location and or cloud data centers. So it's we compile it in one group, and these data centers are in fact large warehouses where a lot of servers, a lot of server racks are included into these warehouses. What do these data center needs? These data centers have a dense capacity, and it's also a critical facility because often there are a lot of transfers of sensitive information like bank data and other sensitive data. So they should maintain the power and cooling the same as for edge computing at all the times. As these data centers are bigger in volume, they're looking for energy efficiency, but they're also looking for scalability. As for example, co-location, initially it takes some time to rent the data center, and it can be that initially only 10% of the data center is occupied. And on top of that, they want to have a fast and quality construction of the data center. So when we think of the cooling solution that meet these demands, we're looking to a cooling capacity in a range from 500 to 5,000 plus tons. And the maximum cooling should be with a low system energy because there is a lot of cooling into these data centers. There should be a certain amount of redundancy, and preferably they're looking for factory assembled components as they're already tested inside the factory. Often we see partnerships in these kind of projects. The end users will buy the same products, they will use the same methodology and the same concept for different data centers all over the world. As mentioned before, the global network is very important, and also the application expertise, the support during design stage, and also afterwards in project stage is very important. So this is the cooling solution that we believe that will meet this kind of data centers. When we look to the solutions that we can provide for this, there are different groups. First of all, you can have the group of the open cooling towers. You have the cross-flow cooling towers. In these ones, the air is coming from sides and the water is coming from the top. You can have it with axial fans. You can have also cross-flow cooling towers with single air intakes. You have the counterflow cooling towers where the air is coming from the bottom and the water is coming from the top. So you see there is a broad range of products. Why is there such a broad range? Because we want to meet the customer demand for each different application. If noise is a problem, there must be solution A. If height restriction is there in the project, there must be solution B. That's why there are different type of cooling towers. Next to the solution with the open cooling towers, we also see a possibility for the closed cooling towers. The big difference is for the closed cooling towers that they prevent that airborne contaminants would enter the system. So there is less possibility on fouling. In these kind of products, there is minimal water treatment and also minimal maintenance required. And we have here a closed loop in a single piece of equipment. We also have, same as for the open towers, we have combined flows, we have counterflows, we have counterflows with centrifugal fans and with axial fans, depending on what are the restrictions in a specific project. And then the last group that we see are the hybrid coolers. We already discussed the modular hybrid cooler, and besides that, there is also an adiabatic cooler. So that works most of the time, it works dry. And if the ambient temperature increases and the capacity cannot be reached, it can work in wet operation due to the adiabatic pads. And next to that, we also have a regular hybrid cooler that can have a wet and a dry coil separately. It can reduce the water consumption with 70% compared to a normal normal fluid cooler. So you see, there are different solutions for different needs in the project. This is part of the data center types and solutions. Now we're coming to the next part where we will discuss a little bit more about the data center trends and more specific about the increasing temperatures. Just to give you an introduction, the data centers were supporting always major innovation trends, IT innovation trends. As you can see, some examples like artificial intelligence, online data mining, things like that. And always they require a larger heat rejection per footprint. Same time, the components, the servers, they allow higher operating temperatures as they are always advancing. So these major innovations have driven an increase in operating temperatures. The question is, how can we allow these higher temperatures and still stay within the server operating conditions? Then we have to go to the beginning. And initially, data centers were using quite low temperatures. But when they were start getting bigger and bigger, they saw that the energy costs were always increasing, and they were thinking to have higher temperatures inside the data center. In 2004, ASHRAE has given a guideline to the industry, and the recommendations for the data centers were to have a server inlet temperature between 20 and 25 degrees Celsius. To have a better understanding what was happening initially inside the data center, to give you an idea, this is traditional air cooling when there is only one room, there is no separation inside the room, and the air is coming, the cold air, via a raised floor into the servers, and hot air is coming out of the server racks. As there is only one room, there is a lot of mixture between the hot and the cold air. Certain points there will be hot spots, but also the cold air will be mixed with the hot air, and the return air will be quite low. So we see here a very low supply temperature and a very low return temperature. Typically, chilled water temperatures, the supply and return were 10 to 15 degrees. And this was how most of the data centers initially were operating. The next step was that there was a hot and cold aisle containment. So in this case, there was a more uniform cold temperature available at the server inlet, and there was no recirculation of the hot air and the cold air. So there was no mixture of these different air streams. So the result was that there was a higher supply temperature possible, and that there was also a higher return temperature possible. So the result was also that the chilled water temperatures were able to increase. So this was the first step, and it was very important that there was a management of the air distribution. Where is it leading to? As we mentioned, there are always major innovation trends, and we already have seen that data center operators were able to manage the air distribution. On top of that, they were using different temperature and control systems. So all this allows the data center operating temperatures to increase, and this has been described in the ASHRAE TC9 recommendations. There you can see two different ranges, the recommended and the allowed. The recommended range provides device reliability and a long lifespan. The allowable range permits a wider tolerance while accepting some potential reliability risk due to different reasons. It can be electrical discharge, or it can be induced temperature failures. So these are now the ranges that the data center operations have as a guideline to use these days. What does it mean, these effects on increase in chilled water temperatures? First of all, the capacity of the chiller will increase, or we can select smaller chillers. A chiller is responsible for let's say 80% of the energy consumption of the water-cooled system. So you can see there is a big saving. And you will also have a more efficient chiller, as you can reduce the condensing temperature of your chiller. So we have a capex and an opex saving, and we can have a low PUE. When you use on top of that Eurovent certified high efficiency evaporative cooling, you can even provide lower condenser temperatures to your chillers by using a very small approach. And the result is that you can even have higher capex and opex savings, which can lead to a much lower PUE and even long free cooling periods. So to summarize this, we had a traditional air cooling. Later on, they start with hot and cold aisles and more management of the airflows, and afterwards also a control of this airflow and temperature controls. This all leads that the supply temperatures were the possible supply temperatures were much higher. This results in also in higher chilled water temperatures. And the final result is that this allows us a year-round free cooling with certified evaporative cooling equipment in certain climate conditions. In other climates, it's not a year-round, but we will see that there is a certain amount of hours during the year that free cooling is possible. And that's a big saving on your overall data center operating costs. So this was about the trends of the requirement for a temperature increase inside the data center, and how they started with the data center and how they come to this much more controlled environments. Now we touched already the topic of free cooling, and this is the last topic I want to discuss a little bit more about. So free cooling, what is free cooling? Free cooling is in fact reducing the use of chillers by using only the cooling tower to cool the chilled water. And why is it important? If we see in the figure where the most of the data center power is going, then we see that cooling represents the biggest part of the data center power consumption. So it's very important to look into that part and to have there the biggest saving, and that can be achieved with free cooling. Also, very typically, when free cooling initially was a secondary mode and the mechanical operation with chillers was a primary mode, we see more and more a shift that free cooling becomes the primary mode and that chiller operation is the secondary or the support mode. When we want to show it on a diagram, free cooling, what does it mean? To give you a little bit more background, this is a traditional cooling tower chiller configuration, and on the right you have the load of the data center. In summer conditions, the data center is cooled by the chiller, and the condenser part of the chiller is cooled by the cooling tower. In winter conditions, when the ambient temperatures drop, the chiller can be omitted and the data center load is cooled immediately by the cooling tower. So this is what they call the free cooling. We always advise the free cooling with closed circuit coolers because there are some advantages. You have a more simple system and less components. You have the closed loop, so there's no contamination. The air cannot reach the process fluid, so you will have no fouling, and you will also have less pump energy required. When we look to the benefits of free cooling, first of all, there's a higher efficiency because there is a minimized use of your compressors. There is also a higher reliability as the compressor lifetime increases. And there is a higher availability and capacity as you have a double cooling source. You have cooling with your cooling towers in case there is a chiller breakdown. And last but not least, there are high energy saving as there is a reduction in chiller energy consumption. And this is probably the most important remark that we can give and the most important benefit with regards to free cooling. When you look to the factors that can impact the free cooling, first there is the geographic location. If you will have a project in the Nordics, it will be much different than you have a project in the south of Spain. It's very important to have accurate weather data. You can find it on ASHRAE site or different other sites that are available, but it's important when you use weather data and you use wet bulbs that you have the correct data of your data center location. Next factor that can impact the free cooling, as discussed, is the separation of hot and cold air streams. You would be surprised, there are a lot of current data centers that are not having this separation yet, and there you can see very high PUEs of above 2. So this is very important to have this separation of hot and cold air streams. And the next point that is very important to pay attention on is the set point of your cooling system. So the server inlet temperature. It depends on the energy consumption and also on the complete architectural design of your data center. And last but not least, the type of cooling technology is very important. As we mentioned, evaporative cooling is using wet bulb temperatures. Typically, wet bulb has 10 degree lower is 10 degree lower than the dry bulb. So with evaporative cooling, you can easily see that you can achieve lower temperatures. So you can provide much lower condenser temperatures to your chiller and can achieve the biggest savings. So we are now reaching the end of the presentation, and I want to give you some key takeaways. I want to tell you that evaporative cooling is one of the most efficient cooling solutions for data centers by providing and improving the reliability by using Eurovent certified evaporative cooling products. You can be assured that the performance is as mentioned on the data sheets. We are looking for very low maintenance and easy inspection units, preferably with cross-flow units. You can have an easy access and very easy maintenance. The energy efficiency is very important, and evaporative cooling is still the most energy efficient method of cooling. And last but not least, we're also looking to sustainability. We're looking to achieve that in our complete supply chain, but also by using alternative materials which can use higher cycle of concentration and reduce the water usage. So these are the key takeaways I want to give you with my presentation. And this are my details. You can always contact me later on if there are any questions.